Dear participants, don't leave the meet. We can continue the session shortly. Thank you. Good evening, sir. Shall we start, sir? Good evening, sir. Shall we start, sir? Good evening, sir. Shall we start, sir? Am I audible to everyone, participants?
Am I audible, ma'am?
Yes, ma'am.
Yes,
You are audible. Yes.
yes, sir. Uh, so shall we start, sir?
Yes, madam.
Thank you, sir. So on behalf of Karpagam Academy of Higher Education and organization team, I would like to welcome our resource person, Dr. S. Pravinth Raja, Professor and Head of the Department, School of Computer Science and Engineering, Presidency University, Bangalore, for the AICTE ATAL Online Faculty Development Program on the topic Harnessing Artificial Intelligence for the Future of Wireless Communication and Signal Processing. He is an accomplished academician and researcher with 20 years of experience in teaching, research, administration, innovation, and international collaboration. He has successfully completed a one-year funded postdoctoral fellowship at the City University of London, United Kingdom, with a research grant of Indian rupees 10 lakhs, demonstrating strong global exposure and research capability. He has made notable contributions to technological innovation and product development, especially through his award-winning projects such as Smart Food Device for Women's Safety and IoT-based dairy yield enhancement systems. His innovations have received major international recognition across Thailand, Malaysia, and South Korea, including runner-up at IEEE Assist 12 2019 Thailand, Gold and Special Awards at I2 Create in the year 2019 Malaysia, Gold at the Innovation Creativity Olympic in the year 2018 South Korea, and Double Gold Award at IEINNO 2018 in Malaysia, and a silver award for the watchdog for mushroom farms in Malaysia. He has been instrumental in capacity building and professional training. As a remote center coordinator, he received successfully $27,000 from the government of India for faculty development programs and an additional amount of $4,000 from IIT Bombay to establish an e-learning center to support online academic delivery and classroom content digitization. Over his academic tenure, he has contributed extensively to research with 80 plus publications, 40 plus patents, 12 Indian patent grants, 2 UK patent grants, and 1 Australian patent grant, reflecting his strong innovation footprint. His research interests span artificial intelligence, embedded computing, IoT smart solutions. He has served as a session chair for IEEE and Spinger conferences held in India and UK. Once again, I welcome you, sir.
Yeah,
Sir,
thank you, madam, for a wonderful intro about me. Thank you, everyone.
Thank you, sir. Sir, can you share your presentation and kindly continue the session, sir? Thank you.
Yes, madam. Sure, I'll share it.
Thank you, sir.
I hope my screen is visible to everyone.
Yes, sir.
Yeah. Okay. So I would like to thank Karpagam Academy of Higher Education, particularly in the Department of Electronics and Communication Engineering, for AICTE ATAL Faculty Development Program titled Harnessing Artificial Intelligence for the Future of Wireless Communication and Signal Processing. I would like to thank the organizers, Dr. Sheila Shobana Rani Madam, and also I would like to thank the convener, Dr. Gayatri, for this wonderful opportunity in the title of Deep Learning Architectures and Applications. So myself, Dr. S. Pravinth Raja, Professor and Head, School of Computer Science and Engineering, Presidency University, Bengaluru. So these are all the overview of the today's presentation in this deep learning architecture. Now we will discuss about introduction to deep learning, evolution of AI, and how it works, deep learning architecture, different types, what are all the various types of deep learning architectures are available, and different applications across industries with respect to deep learning, and few case studies for your kind information. This is a overview about the today's presentation. Let me see about the introduction part of deep learning. So what is deep learning? So we may heard about the word recently, AI, artificial intelligence, machine learning, deep learning. So this deep learning is a subset of machine learning. After the machine learning only, the deep learning came into the picture, came into the real world. It using multiple layered artificial neural networks. If you have larger volume of data, and if you want to identify who is authorized person, who is intruder, or who is fake, so we will use this deep learning to identify the wrong person in simple way. So it is a subset of machine learning, and this deep learning learns itself automatically by using patterns. Example, when you keep on watch the reels of a particular YouTuber, whatever the reels you are seeing, further reels, the YouTube will suggest you the same kind of YouTuber reels. It will learn the patterns automatically. When I am keep on watching some videos particular to the sports, so whatever the reels you are going to see in future, the YouTube also will recommend the same set of reels, same set of videos. That means based on your input, it automatically recognize that you want to see a particular YouTuber videos example. So that is the key idea of deep learning. This model learns the patterns automatically. No need to give any forms, no need to give any details. I want to see only sports. I want to see only this type of agriculture. I want to see only this type of learning. No, based on your input, it automatically learns. So that is the key idea behind the deep learning. We will go one by one. Initially, I have taken few examples from cyber security for your better understanding. I hope some faculty belongs to electronics and communication engineering platform. Some faculties belongs to computer science and engineering platform, and some of them may be in electrical and electronics. So I'll try to give very simple content for your better understanding, so that you will get an idea what is deep learning and where this deep learning is used in real world applications. Let me move on to the next slide about why is it powerful and what are all the applications. Because when you're handling the larger volume of data, so we need a powerful tool, and this tool should be a very simple one which can be used by everyone and which can be executed the task in the shortest duration of time. When you are making payment in Paytm, it takes very nanoseconds or microseconds to transfer the money to one end to another end. If it takes 1 hour for transfer the money, no one will like the Paytm or Google Pay. Like that, whenever you are applying this deep learning things, it should be executed within the shortest span of time. So it executes, it is very simple, and it is more powerful than the earlier models of machine learning and rule based methods. So that is the reason it can handle the larger volume of data and it produces the output. That is the reason for using this deep learning architectures. I will show few uh, fundamentals how deep learning came into the picture quickly with some case studies. Then I will enter into the architecture part of deep learning. So this is a representation of evolution of AI. We are hearing this AI recently, maybe after 2020, but the early AIs, it started in the year of 1950s to 1980s in Turing test. After that, in 1943 to 1986, neural networks came into the pictures. You know, this neural networks behind the screen of our brain, how our brain works, based on the neurons. So same concept, we have the input, we have the layers, we have the output. Based on that, the neural networks came in 1986. Then after neural networks, machine learning came into the picture, 1980s to 2000. After, a deep learning is an era from 2010 to present. We are all using deep learning. After that also, we have a AlexNet, like various applications of CNN, RNN, transformers, and GPTs. Okay, so this is the representation of evolution of AI. Earlier AI, neural networks, machine learning, and deep learning. Let me see few examples quickly. So the earlier AI, it is called as rule-based AI. That is the first generation. Example, it will produce either 0 or it will produce result as 1. Either 0 or 1. That is called as if-then logic. Either it is true or it is false. When you are trying to attach some document in some link, so the the sender has clearly mentioned your document size should be less than 10. So if you are trying to upload 11 MB, it will check whether it is less than 10 or greater than 10. If it is less than 10, you can submit the form. If it is greater than 10, you cannot submit the form, because the rule says that there is no possibility to upload your documents. So before introducing the AI, we have a rule-based mechanisms, either true or false, 0 or 1, pass or fail, fit or unfit, like that. These people have been used this rule-based AI. Because of this rule-based AI, so many incidents happened in the world. There may be a big loss. If you take a cyber security area, there was a big loss in the year 2010 in the location of Iran. So the virus came into the system through the USB drive, and whatever the enrichment centrifuges, 1000 plus centrifuges has been spoiled because of this rule based method. I am taking a just example of cyber security. Okay, so this is the first incident happened in this internet era in 2010 in Iran. So when the people have started to use rule based method, yes or no, true or false, 0 or 1, big incident, tragedy has happened, and the people has affected with lot of data, loss of data. And another incident in 2013 in USA, there are 110 million customers, they lost their payment because of this rule based AI methods. This is the previous history how the deep learning came into the picture. And around 200 million users, and in USA, they filed a case against, they have their details, their data, credit card data, like username, passwords has been stolen because of this rule-based AI. So the people thought that rule-based AI will not give the solution. we have to move to the next technology, that is the entry of AI and ML. So earlier, like as per the history era of AI, earlier we used rule-based AI. Because of this rule-based AI, there are so many confusions, so many data breached, and so many data has been lost, money has been lost, and the customers has filed a case against to the banking sectors. So the people decided that rule-based AI will not give the accuracy. So they moved to AI and ML, artificial intelligence and ML. So what is artificial intelligence? In simple way, it behave like a human. It take decision like a human. So that is an entry of AI. Whenever a human being is taking a decision, instead of rule like 0 or 1, true or false, pass or fail, this AI will take the decision, will understand the scenario, the background scenario, and it will take the decision. That is AI. It think like a human, it behave like a human, and that is an era of machine learning. It is a subset of AI. It comes from AI only, machine learning. Okay, so instead of fixed rules, we will train some patterns to the machine. It is a machine, it is not like a human. if you teach if you teach the machine with the photo of your puppy, your dog, and how many photos you are giving food to the machine, 100 photos of dog, then the machine will understand if this pattern comes, this is like a dog. When you test your machine with some cat picture, so it will recognize that this is not a dog, this is a cat. So that is a representation of ML. So what you supposed to feed your machine, what it needs actually, you have to feed your machine with raw data like dog pictures or dog images, and you have to train your model. Okay, learning from the processed information, whatever the image you want to train your model, you have to train, and you have to give some pattern. A dog face is look like this, yeah, ears look like this, nose look like this, eyes look like this, the shape look like this. Then finally, whatever the image you want to test to your machine, it will give the output, it will give the result as this is this is a dog, or this is a not a dog. So that is the representation of machine learning. Again, machine learning also have some various drawbacks, various issues the people has faced in the uh, in the scenario while they are using machine learning. Example, whenever nowadays also, whenever you are trying to log in your Gmail with other IP address, as usual, you used to log in your Gmail with your laptop or with your uh, office systems. But when you are trying to log in the Gmail with other IP address, maybe you are visiting to Chennai, or you are visiting to Hyderabad or Bengaluru, there you are logging with another device, it will detect some suspicious activity. So this is a best example of ML which is came into the picture. Again, ML model learns the patterns every day. Every day you are logging at 9 and you are log off at 5 p.m. When you are trying to log in at 2 a.m. in Secunderabad, Hyderabad, it will detect that. So there is some pattern has changed. My user usually log in at morning 9 a.m. and log out at 5 p.m. But this user has logged in at 2 a.m. in Hyderabad. Location also has been changed. So it will detect like that. So that is a representation of ML, real world applications. Again, ML also have some various drawbacks. So this is the representation of ML: input, learning, detection, feedback, and improvement. So in 2017, USA and UK, around 230,000 computers within 48 hours, the security has been breached because of intruders. Because till 2017, this incident, people has used this ML based algorithm to protect their systems. This is the type of uh, ransomware attack. You may also hear this ransomware attack in 2017 in USA and UK. So the people has decided that there is a big impact because of this ransomware incident. Nearly 4 billion global has damages. The customer has lost their data, lost their security details. So people has decided that rule based will not give you the better solution, and people has decided that AI and the ML will not give you the best solution. So we have to move on to the next model, that is called as deep learning model. That is the era of deep learning comes into the picture. So this is nothing but a neural networks, a combination of neural networks connected to each other, and it will automatically learns its features. Like how I have given one example. Whenever you are keep on watching the YouTube reels, so whenever each slide, when you are sliding up, the same type of videos will be pushed into your account. When you have a Amazon uh, Prime, when you have a Netflix account, when you are always likes to watch, yeah, comedy videos, comedy films, when new comedy films comes into the Netflix, you will get the notification your favorite Tamil or English comedy movie is in Netflix now, because you would like to see only the Netflix in particularly comedy related films. So this is what an example of deep learning. So it automatically learns, it automatically generates the details, it automatically generates the reports with respect to the user expectation, with respect to the user interest. That is what the representation of deep learning. Okay. So how this deep learning works? So initially, whatever the mechanisms, whatever the method, you can take machine learning, or you can take AI, or you can take or deep learning, or in further future models. It always starts with data collection. What is your input? What is your input data? Which data you are giving as an input to the system? Whether you are giving input to the system as a images, whether you are giving input as a system to the mathematical data, or whether you are giving input as a algorithms or formula. So that is also to be considered as very important criteria whenever you are executing the task with deep learning. Okay, so here also the representation, the first data starts with data collection. So nowadays many datas are there, many uh, uh, inputs are there. You can take the inputs from Kaggle, whatever it may be. It may be a cancer related data set, it may be a plant related data set, or it may be a credit card related data set. Everything details are available. So always a learning mechanism starts with data collection. So whatever the data, so that is the first. The data may be, yeah, images, or your data may be text, or your data may be an audio, or your data may be a sensor data like an IoT devices. You are extracting the temperature of each minute in your house. It is also called as a data. So whenever you are feeding your machine with more number of food, when you give more food to your puppy, so your dog will be, yes, bigger sizes. Similarly, whenever you are feeding your system, whenever you are feeding your machine with more number of data, you will get very good accuracy. So when you train your system with 100 images, the accuracy may vary from 1,000 images. So the first, it starts with data collection, and the second step deals with data pre-processing. So pre-processing is nothing but removing some unwanted noises in the images, or removing some unwanted noises in the text, removing some unwanted content in the audio or sensor data. So that is the representation of step number 2, pre-processing. Like if you want to give input to your system only 2 by 2 size of images, but my input image has 3 by 3, then I have to step down to 3 by 3 images to 2 by 2. Or some background, some other content is also there in my text, or in the text there are some words are repeated, some words are irrelevant, some words spellings are mistakenly given. So this is to be taken care in the pre-processing step, that is called as normalization, resizing, tokenization, noise removal. Okay. And also you have to clearly mention, you have to train your system by 70% of the data, validation by 15%, and testing by 15%. That is called as valid training and testing in simple way. I have to train my system 70 and I will test by 30%. That is the second step of data pre-processing, normalization, and I have to split the data set into training and testing. So once if it is pre-processing has been done, I have removed the unwanted data in my input, then I will move to the forward pass. So forward pass in the deep learning architecture, it is nothing but the input can be passed into multiple layers. So that is the specialty of the deep learning architecture. So each layer, it will be passed from one to another. So these layers are called as hidden layers. These layers generally called as hidden layers. So that is step number 3, forward pass. I am passing this image into multiple layers, multiple hidden layers. That is a representation of a deep learning architecture, forward pass. So once the input has been passed, the input has been um, um, crossed into the multiple layers, then it will be pushed into the next step of loss calculation. So here I am calculating how many the errors I am going to get it. What are all the losses like MSE, cross entropy? So these losses measure in this loss calculation. After that, it will be moved to the back propagation. Some adjustments like whenever I am getting the inputs, some adjustments, weight adjustments I have to set to reduce the errors in my output. So this back propagation also to be one of the important step in the deep learning architecture. So after this propagation, then I can go to the real training model of my system, that is called as model training. So you can use the various algorithm to train your model in this deep learning architecture. Finally, you can go for testing, and what is the exacted results you have received through your deep learning architecture, that is a final output of your model. So it starts with input, that is called as data collection, and it will goes to till the output after passing this data pre-processing, followed by forward pass, then loss calculation, back propagation, model training, and testing prediction. That is predicted whether it is a dog or whether it is a cat. By following these steps, the deep learning will produce the results from input to the output. These are all the steps it has to be carried out in each steps. Representation of deep learning, how it works. Let me move to the main agenda of the session, deep learning architecture. So far, we have seen the era of deep learning. It starts from rule-based AI and machine learning algorithm. After that, deep learning, then how deep learning works based on the steps we have seen. Next, we are moving to what are all the different deep learning architectures are available. So there are 8 different types of deep learning architectures are there. It starts from feed forward network. This is the first architectural style comes under deep learning. So feed forward networks. This is a very simple method, and you can take the unidirectional data. Okay. So in the next slide, I will explain what are all the applications or where we have to use this feed forward networks. Detailed we will discuss in the upcoming slides. I will tell you the overview about deep learning architectures, different types, feed forward networks, and we'll move to the second type, convolutional networks. This can be specialized for image, particularly computer vision area. If your input is an image, you want to do something with the image, fake, real image, or plant leaf disease, or uh, cancer diseases, whatever the data you want to do with the image, you can go for this convolutional network type of architectures. And the sequence model, particularly for NLP, natural language processing, my input is not an image, my input is a voice, my input is a speech recognition, who is speaking, who is the user. So these type of designated task, you can go for sequence models that is designed for temporal data like speech and time series. That is the third type of deep learning architecture model. And fourth one is attention model. It is focused, relevant for the particular parts of input data. My input is not image, my input is not speech, my input is particularly uh, yeah, yeah, data coming from my IoT sensor. Example, I want to check whether the today's temperature is hot or cool. So it is based on my input coming from IoT temperature sensor. If it is less than 10 degree, then you can redraw the output as, you can mention the output as temperature is too cool, and if it is above 20 or 30, you can mention as temperature is too hot. So for some specialized input, you can use this architectural model of attention models. And generative models, so the model itself will generate the data, automatically learn the data. So generative models, that is the fifth type of deep learning architecture. Then graph networks. This is with respect to big data or data analytics. When the customer is buying more number of product in the Flipkart, whenever you are searching to buy some headphones, so which customer has purchased more branded headphones. So these related big data and data science with related to the big data, you can use this graph networks. And reinforcement learning, this is also another type of architecture. In the first time, you will not get the desired output, you may get some errors, you may get some very lower accuracy. So keep on, it will try with trial and error methods, that is called as reinforcement learning method. And finally, hybrid architectures, you can combine multiple type of architectures into the deep learning method. So these are all the overview about various deep learning architectures. Since the given session with respect to deep learning architecture, mostly I will cover the deep learning architecture model, and I will take one model as an example how this deep learning model produces the output at the end of the session. Let me move on to the deep learning architecture step by step, like each model by model. Example, feed forward architecture. Again, feed forward architecture have many types: perceptron, MLP, DNN. So what is MLP? Multi-layer perceptron. DNN, deep neural networks, and each one have the various examples, use cases. Based on your need, you can choose the model. Even in feed forward architecture, which model you want. Either you want perceptron, you want to check whether your input email is a spam email or not spam email. So you can use perceptron, or you can use a handwritten digit classification. Like you want to recognize this handwriting belongs to person X, this handwriting belongs to person Y. You can go for multi-layer perceptron, that is called as MNIST, handwritten digit classification. And if you want, you can go for deep neural networks, DNN model for fraud detection, tabular data prediction, and credit risk scoring. When the bank people is trying to give loan for the particular customer, what is the risk factor involved in it, whether the person has properly paid all the EMI earlier with respect to the previous loans. So they will predict what is the risk involved in it. That is what usually we are getting the score of credit card scores we used to get now while applying the bank loans, generally called as CIBIL score. Yes, the same type of application with respect to deep neural networks. Move on to the second type of architecture, convolution based model. I like this model very much because my research area belongs to the image processing. So most of the architecture I used to have in my research articles. Like the best model is CNN, not the best model. So CNN, mostly we used this model, CNN, for object detection, image classification. So when you are uploading some pictures in Facebook, so along with you and your friends are there, immediately the Facebook server will detect the image belongs to some another person name, and it will ask to you whether you want to tag to this person. It is based on the CNN. It's exactly called as object detection. It will detect the objects, whether this object belongs to the chair, whether this object belongs to the table, object belongs to the sofa, object belongs to the refrigerator, object belongs to the TV. So the object detection purpose, we will use this architecture CNN model. Then another model is called as LeNet. So what is LeNet? LeNet is nothing but the person who implemented, the person who developed this model, Lee Kun. Though that is why this model is called as LeNet model for recognizing the digits. Example, whenever you are paying the money in Paytm, if you paid 80 rupees, example, immediately that 80, the digit is to be recognized. Immediately the 88 digital number and 0, it will be converted as a speech. Immediately you are hearing the uh, voice as received 80 rupees money with the proper template. So that is a representation of LeNet, LeConNet. Then AlexNet. Similarly, AlexNet also, the person who developed this model, Alex, the person name is called as Alex. That is why it's called as AlexNet. So this AlexNet can also be used for larger scale image recognition. When you want to check the person whether this person is genuine or imposter with larger volume of data, you can use this AlexNet CNN architecture. Then VGG is nothing but visual visual geometry, VGG. When your input is always a video, your input is not an image, your input is a video. From that video you want to identify who is the thief is coming into the particular place, or who is the person who is coming into the particular shop. So you can use this VGG net for face recognition and medical imaging. Then Google Net for higher accuracy, real time vision task, and ResNet, residual networks, particularly the Tesla and all using this architecture, residual network architecture for self-driving cars, facial verification. So some of the doors nowadays they have implemented for face verification. When you show your face, the doors will be locked and the doors will be unlocked. So the architecture behind this facial verification and self-driving cars, when one object is going in before the car, means it will detect and it will reduce the speed. Particularly Tesla and other Google is trying this ResNet, residual networks, with respect to the applications of deep learning network. And DenseNet, particularly in the medical imaging, X-rays, CT images, whether the person is having the infections in the lungs, infections in the liver, by using X-rays and CT images, they are using DenseNet. And when you want to implement these applications in the mobile, so you can go for mobile net. And if you want a higher accuracy, you can go for this efficient net. And vision transformer also you can use nowadays for image processing and the document understanding purpose. We will use vision transformers also. So this is the second type of deep learning architecture, comes under convolutional based models, mostly image based. That is why it comes under computer vision. And the third type of architecture model is sequence and temporal model. So there are five types of architectures here: RNN, LSTM, GRU, bidirectional, deep belief network. So what is RNN? Recurrent neural network, which can be used particularly for data prediction. So many of the people has advertised AI data prediction of stock trends, which stock will go higher price, which stock will go to the lower price as per the today's environment. So those data prediction, and even some environmental today, whether rain will come prediction based on 5 years of data. Today's December 12 at 6. What about the 5 years of data temperature about the same day, same time, same date? So based on the 5 years cumulative data, it will predict whether rain will come today or rain will not come today. So these type of networks comes under recurrent neural network. Then LSTM. So if your project belongs to speech to text or text to speech, so you can use this LSTM model, long short term memory. And weather predictions also you can use LSTM model. Even chatbots nowadays we are using this LSTM, long short term memory architectures in deep learning for predicting the data. And gated recurrent unit, that is called as GRU, real time language translation. Some of the students may do some project. When I speak in English, the English will be converted into Hindi, English will be converted into Tamil, English will be converted into some other language. Real time language translation, you can use this architecture, GRU, gated recurrent unit. Then bidirectional LSTM, sentiment analysis, named entity recognition. Sentiment analysis is nothing but based on the review. I want to book a hotel. So based on, there are 100 reviews are there. There are 70 reviewers are suggested good and 30 reviewers are suggested worst. Don't stay this hotel. Don't book this hotel. So out of this 100 reviews, I can give this 100 review as an input to my system, and the system will remove the unwanted data, and finally the system will give whether these reviews are real reviews or whether these reviews are fake reviews. That is called as sentiment analysis. You can use this bidirectional long short term memory architecture in deep learning. Particularly this architecture comes under sequence and temporal model. Then deep belief networks, which is called as DBN. If you want to extract the features in the speech recognition, if I am pronouncing a particular word, features, school, university, college, what about my pronunciation? So it will be calculate the exact pronunciation of the particular person by using this DBN network. So this is the third type of architecture with respect to various applications. And the fourth type of architecture is attention and transformer architectures. So here there are very best models are there. BERT model. So that is bidirectional encoder representation from transformer. Like most of the chatting mechanism like Alexa, Google Alexa and all, they will use this best model. When I am asking my Alexa, so what is the today's time? What about the current time? What about the current temperature? So based on question answering, document search, text classification, that is also will be used this BERT model. Example, you may have seen when you are opening some web pages, websites, immediately AI support will come. How I can assist you? What is the question? You can post your question here. So those type of architectures comes under BERT, bidirectional encoder representation from transformers. And GPT series, that is generative pre-trained transformer. It is the representation of conversational AI and content generation. If you want to generate the content, example, the chat GPT is the best example, comes under this transformer architectures. And T5, T5 is nothing but 5 times T, that is text to text transfer transformer, transformer. Like if you want to summarize anything like question and answers, translations uniformly, so you can use this T5 architecture. Then XLNet, extra long network, particularly for sentiment analysis, just now we have discussed. And vision transformers, particularly for image classification. If I want to classify the image, these images are apples, these images are orange, these images are pomegranate, these images are pineapple. So if I want to classify the images in deep learning neural network, so you can use this transformer architectures. And if you want to apply any diffusion transformers, you can use this AI image generations as one of the type of architectures. Then the fifth CNN architecture model, deep learning architecture model, is generative model. So in generative model, we have a auto encoders, then variational auto encoders, VAE, then GAN, like DC GAN, cycle GAN, and style GAN, and diffusion models. So these are all the various models available in the generative model architectures for image or noise removal, image synthesis, deep fake generation, then photorealistic image generation from various type of resources. So if your application related to the image based or deep fake based or photorealistic based, you can use this generative model to take the exacted outputs. And the sixth model is graph-based neural networks. Graph neural network. So a molecule structure prediction. What about the cells in the blood? And what about the diseases with respect to the gene prediction, recommendation system, traffic prediction, and large scale graph learning for LinkedIn or Facebook connections. If your application is related to these type of data, you can go ahead with this graph based neural networks. You can use any one of the architecture, GNN architecture, GCN architecture, graph attention or network, GAT, and graph sage, that is sample and aggregate. The seventh deep reinforcement learning architecture is DQN, deep quality network, that is for particularly used for robot navigation. When you are designing a robot and the robot has to move forward, left, right, and back, so you can go for this deep quality network architecture comes under deep learning. This is the type of deep reinforcement learning architecture. Then policy gradient, that is also you want to implement. The robot will take one object from one place to another place, move one object from one place to another place, robotic on arm movement. So you can use this policy gradient in deep reinforcement learning architectures. Autonomous drones, warehouse autonomous, then open AI, humanoid robots. So when your application is falling under robotics, you can go for deep reinforcement learning without the second opinion. Representation of architectures, DQN, policy gradient, actor critic A to C or A3C, PPO, that is proximal policy optimizations, deep reinforcement learning. And the last type of architecture comes under deep learning is hybrid or specialized architecture. If you want to combine more number of architectures, two architectures into one, you can go for this hybrid specialized or hybrid or specialized architecture. Example, capsule networks. Capsules is nothing but we have an outer cover and inside we have the medicines. Similarly, outer you can use one architecture and inside for feature extraction, feature classification, feature recognition, you can use some another architecture model that is called as capsule networks. And neural ODE like climate modeling, biological simulations, spiking neural networks like neuromorphic hardware, brain like computing, federated deep learning, and NAS, neural architectural systems for automatic model designing purpose. So these things you can use um, in hybrid or specialized architectures in deep learning for with respect to the applications of 3D object understanding, climate modeling, neuromorphics, and privacy preserving mobile AI. So these are all the various 8 types of deep learning architectures currently available. With respect to your applications, you can choose either hybrid or you can choose a robotic type of applications, you can use CNN type of applications, you can use reinforcement learning applications, or you can use feed forward neural networks. So it's all about depends on your applications where you will use this deep learning architectures. So based on that, you can pick any one of the architecture and you can implement your proposed model in your research purpose or in your project purpose or in your uh, real world hardware based models also. You can use this any one of the 8 architecture. As far as my suggestion, the best three as far as my suggestion, the best three uh, deep learning models comes under CNN is the first model is efficient net. It produces the better accuracy, highest accuracy, and you have to give very few parameters only. Uh, you, you should not, you don't need to give more number of parameters to predict the model, to predict the data. So as far as efficient net is producing the better accuracy than other deep learning models. Then the second place goes to the ResNet, that is residual networks. Okay, so it is also comes under the deep learning architecture. It enables the deep networks with residual connections. And the third one, the best three I have listed out here based on the accuracy and the strong performance. Okay, so based on some parameters. And the last one is dense networks. It connects all the layers for efficient future reusing purpose, this dense net is used to produce the better accuracy. So out of this 8 various architectural models, my suggestion, you can go for efficient net or rest net or dense net. Again, it may vary from your applications. Your applications belongs to image, or it belongs to the robots arms designing, or you can go for data, you can go for prediction, you can go for analysis. It is based on that, but overall these networks will produce the better accuracy, efficient net, rest net, and dense net. I want to show a overview of how this efficient net works. That is the last part of the presentation. I hope you are all listening and you are spending your valuable time here. So how this efficient net works, we'll have a quick glimpses, then we will wind up the session with applications of deep learning architectures. Okay, so efficient net. So what is efficient net? So this efficient net comes under the deep learning, particularly a convolutional neural networks. So what is the purpose? It has to produce the better accuracy, better performance with respect to the previous architectures. There are so many architectures we have seen, but this efficient net will produce the better accuracy. Accuracy means better results, better performance. That is why we have to proceed with efficient net. It is a family, that is a subset of convolutional neural networks. This one was introduced by Mingxing Tan and Kyok V. Lee from Google Research in their 2019 research paper. They have introduced this concept, efficient net rethinking model scaling for convolutional neural network. So this is based on scaling, how the input has been scaled into different types and how this results can be calculated. So we'll move on to efficient net, how it works. So in particularly, efficient net will use B0 architectural model, the B0 network model. So the B0 network model consists of 3 parts. One is stem, another one is body, then third one is head. So what it covers? Stem covers. So the stem covers initial layers and consist of 32 filters and the kernel size of 3 by 3. So the stem is, they have covered, they have represented this B0 architecture for a tree. How the tree consists of stem, body, and head portion. Similarly, the stem is nothing but a layers, and the body, that is an important here, MB convolutional, that is invented MB convolutional blocks with different configurations. So here each blocks, so whenever your input is an image, the image consists of n number of blocks. So each blocks will be analyzed in depth wise. So that is the representation of MB convolutional. So that is the representation of efficient net in terms of body. And the third one is head. So head is nothing but the average. So the deep learning consists of various layers. So this is the one of the layer of pooling layer, and in this pooling layer, so the input will be passed and how it is producing the desired output. Okay, so that is the representation of head part in the B0 architecture. So what is MB convolution? MB convolution is nothing but mobile inverted bottleneck. So that is the short word of MB, mobile inverted bottleneck. So that is a representation of MB, mobile bottleneck. So this efficient net is using B0 architecture. So this is an overview of B0 architecture. So it efficient net. So how this architecture works? So what is behind in this B0 architecture? So in B0 architecture, they are using a method, a coefficient which is called as compound coefficient. So whatever the images are there, this compound coefficient will not resize the image randomly, will not randomly resize the image with wider, with depther, with changing the resolution. No. So it will use some formula. It use some standard procedure for resizing the images. That is the main heart of this uh, B0 architectural model. So that is the main heart of this compound scaling method. So in this compound scaling method, so there are different types of scalings are used in earlier, but this compound scaling is a different, and it is better than the previous earlier versions. So that is the heart of efficient net. If somebody has asked how the efficient net is working in deep learning architecture, you can directly say based on compound scaling method. So it will adjust the network width, depth, and resolution automatically instead of random expanding the size of an image. Will show. So hope you have seen this, seeing this image. The right hand side image, like the representation of E, that is the efficient net architectural model. That is the compound scaling architectural model. So here in depth wise it is scanning the image, and wider wise also it is expanding the image, and resolution wise also it is expanding the image. All the three parameters, depth wise, wide wise, and resolution wise, it is expanding the images. So that is the compound scaling heart of this efficient net method. But earlier method, if you see image A baseline method, it will detect only the bases, and if you see the image B, it will check only the wider part of the image, and depth scaling in C, it will check only the deeper part of the image. If you see image D, it will take only the resolution part. So these are all the convolutional scaling methods, like with respect to the depth, with respect to the scaling, with respect to the baseline. Baseline means nothing. Yeah, whatever the images has given, without scaling, the image will be taken into the consideration. But here in compound scaling method, depth is also to be considered, and width is also to be considered, and resolution also to be considered, so that you will get higher accuracy. So how this efficient net works? First step, you have to feed the image as an input. Then if you are feeding image as an input, okay, this efficient model receives your input, and it will extract the features, whatever the features are there, like distance between the eyes, distance between the nose, distance between the lips. So these are all the features. If you're giving input as a image, like a leaf image, so what is the size of the leaf, how many inside neurons are there, so nerves are there, how many nerves are there, what is the pattern of the leaf, all those things to be extracted. That is called as feature extraction. Then this feature has to be converted into mobile inverted bottleneck. That is the highlighted method used in efficient net, MB convolution. So that is to be applied. Then after that, feature has been extracted from lower level to higher level, and it will be converted into two-dimensional to three-dimensional, or one-dimensional to three-dimensional. That is spatial compression. And finally, it is classifying from whether this is a dog or it is a cat, whether it is an orange or apple, this is an apple or pineapple. So that is to be classified here. Then we will predict the output, whether the person is having the cancer or not cancer, the person is a girl or boy, the person is having diseases or not diseases, uh, whether the rain will come or not come, what about the temperature. So all the predictions will be happened at the end of the output layer called as softmax layer. So it starts from the input and finally it will be entered into the prediction. For your better understanding, I will take one case study as plant leaf disease case study. When your input is a leaf image, finally your system will predict that the leaf have a disease or the leaf have a not have the diseases. So I have to give the leaf images, raw leaf images as a input to my system. So if you have taken the leaf image, some background unwanted content also to be there, so that is to be removed in the pre-processing, and whatever the size you want, that is to be resized in the pre-processing. Then I am training my model. Already I have trained my model. If this black color dot comes, this is the name of the disease. If red color dot comes, this is the name of the disease. If yellow color, light shadow of yellow comes, this is the disease. So I already trained my model. So now your leaf will be extracting the features. Your model has extracting the features. If black color dot comes, then it will classify that this is the type of disease name. If yellow color comes, this is the type of disease names. If green color or red color, so it will be classified, and finally it will predict the disease name, whether it is anthrax, whether it is a powder, or whether it is a mildew disease. So based on the classification, it will be predicted the different types of diseases. So this is also a step-by-step procedure of how this efficient net works, particularly for the case study of plant leaf diseases. Okay. So with respect to the algorithm, what are all the algorithm I have to use? So here I have tabulated. So for feeding the raw input image, you no need of any algorithm. A raw leaf image can be given as an input, and if you want to pre-process it, so raw leaf image is an input, and the images will be pre-processed like normalized, pixel scaling from 0 to 1, and data augmentation like rotation, flip, or brightness adjustment, resizing the image. So these are all the operations performed in the pre-processing. Then feature extraction. So you can use CNN, compound scaling plus MB convolutional plus SE blocks algorithm for extracting the features. And after extracting the features, you can go for classification, and finally you will get the desired output. A step-by-step process of and which algorithm is to be used and which input has been given, what is the desired output. Finally, once if you give the input as a leaf image, as a raw image collection, finally your system will predict that what is the disease in that particular leaf, whether disease is there, or if there is no diseases, then it will predict that there is no disease occurred in the leaf images. So a step-by-step procedure for efficient net with respect to the case study of plant leaf disease detection. So we have used earlier rule-based AI. After that, we have jumped to machine learning model. From machine learning to we have jumped to deep learning model. Even though there are so many drawbacks in the deep learning model, that is why now we are all using explainable AI, which is called as XAI. That is the current trend of AI method. This explainable AI have uh, two methods. One is shapely additive explanations. With respect to the time constraint, I am quickly moving to the next one. I have given some case studies also for your better understanding. Why deep learning has not satisfied, we are moving to the explainable AI. one of the method, shapely additive explanation. Then another method is called as line. So local interpredictable model. This is also used in explainable AI method, generally called as XAI, explainable AI. Okay, either you can use shape method, you can use line method in explainable AI. Okay, so even after explainable AI, now people are moving to some mm, moving to the futuristic AI model that I will tabulate, I will show at the end of the presentation. So these are all the various applications of deep learning across industries. Uh, if you want to identify the person face, whether the person is a fake or intruder, particularly in autonomous vehicles without the drivers, Tesla computer vision is one of the best application of deep learning. Natural language processing, example, Chat GPT is the best example for deep learning. Then generative AI, you can give some content, it will generate the image. That is generative AI model. Then healthcare applications like drug discovery, disease identifications, finance, whether I can give the loan to this person or not to give the loan, or what about the data analytics like stock prediction, that also we have seen. Finance, robotics like reinforcement learning, robotics arm designing, robotic steps taking forward, that is also in one of the applications of deep learning model. Then IoT sensors like smart homes, when the person is entering into the house, automatically lights will be turned on, fan will be turned on, ACs will be turned on. So that is also in another application. With respect to cyber security, deep learning also playing the major part in the environment. So with respect to computer vision, NLP, Gen AI, healthcare, finance, robotics, IoT, and security, there is a vast applications, deep learning playing major role in the industry and also real world applications. So this is for your kind information um, from rule based AI to Gen AI. So now we are all using deep learning, but even though there are better technologies came, we have discussed the line model, shape model in XAI, explainable AI. Again, explainable AI can also have some drawbacks. We moved to Gen AI model. So generative AIs, Chat GPTs, DAL-E model, stable diffusion, Gemini AI. So these are all the best real world applications of Gen AI model. Even now, people are telling Gen AI is also outdated. We are moving to agentic AI. Agentic AI, that is a future version of Gen AI. Agentic AI. People are working in the research how Gen AI can be implemented for these various real world applications for medical diagnosis, spam detection, face recognition, loan approval, and content generation. So maybe in future this agentic AI may play the major role in the computer science and engineering field, not only in CSE. Nowadays, everywhere, this AI playing a major role. So this is for your kind information. We have started the journey from rule-based AI, and we have discussed various architectures of deep learning, 8 architectures we have seen, and also particularly the best model, efficient net, how this efficient net works, how one input of leaf can be decided into the decision of whether the leaf have the diseases or whether the leaf have not affected with the diseases. In the deep learning architecture we have seen, not only deep learning, advanced versions also came into the picture like explainable AI and generative AI. Now this is your turn. Which methodology you are using in your research, whether you are using deep learning or XAI or Gen AI or machine learning algorithm. So still you have not identified your research. When you are going to find out your research topic, my suggestion, you can go for Gen AI or agentic AI, because in the next 4 years this one will playing the major role in the research part. Okay, so these are all the overview about the today's session, deep learning architectures. I have not covered the deep learning architectures, and also we have covered how deep learning came into the picture and in future trends like XAI, Gen AI, and agentic AIs. Okay, so thanks for the opportunity today given to me to take the session of uh, deep learning architectures in the ATAL FDP.
Thank you, sir, for your
So
wonderful.
I would like to thank the organizers of this deep learning and architectures of this ATAL FTP session, and I thank the management um, and my university people also for gave me the opportunity to present the session in this ATAL FTP. Thank you, everyone. Thanks for patiently listening the session. I have taken nearly more than 1.5 hours. So thanks for patienting. Thanks for listening the session. Thank you, everyone.
Thank you, sir, for your wonderful presentation. Participants, any questions? Sir, shall we conclude, sir? Dear sir, we would like to express our heartfelt gratitude for your enlightening session on deep learning architectures and applications. Your presentation provided us with a clear understanding of complex concepts from foundational architectures to real-world applications. The way you illustrated practical use cases, connected them to emerging, made the session more engaging and highly relevant. Your expertise and ability to simplify intricate topics have inspired us to explore deeper into the field of artificial intelligence. The knowledge you share will undoubtedly guide us in our academic as well as in our professional pursuits. Thank you once again for dedicating your time and effort to enrich our learning experience. Once again, I thank you, sir.
Thank you, madam, for the wonderful opportunity you have given to me for taking the session in your university, particularly the title of Harnessing Artificial Intelligence for the Future of Wireless Communication and Signal Processing, ATAL FTP. Kindly collect the feedback from the participants so that it would be helpful for me to handle the another sessions in the upcoming days. Thanks for the opportunity. Special thanks to Dr. Sheila, Madam, for giving me the opportunity, and special thanks to you, Dr. Gayatri. Thank you, everyone.
Thank you, sir. We will be collecting the feedback and will update in future, sir. Thank you. Thank you, sir. Dear participants, I kindly request everyone to post the attendance and come feedback form using the link which has been posted in the chat box.
Hello, madam. Any other attendance form we separate or feedback?
Yes, sir. There will be a separate attendance form for session 3 and session 4. The link has been posted in
But
the
we
chat.
posted only feedback form only, ma'am. Yesterday also.
So, attendance and feedback session form will be attendance come feedback will be available in the single session form, sir, single Google form. So you'll be having a separate attendance come feedback for different sessions, session 1, 2, 3, and 4.
Okay, thank you.
Okay, sir. I thank all the participants for your patient listening, and let's all meet tomorrow by 6 p.m. for the next session. Thank you all. Once again, I kindly request the participants to fill the attendance come feedback form, which has been posted in the chat box as well as in the WhatsApp group. And if you have completed meets, then kindly leave the meet. Thank you all. Participants, if you are kindly posted the attendance meets, please leave the meet. Thank you.